Okay, fine. So now I'll start writing the program for this profile. So I think it is Okay, so this is the part sketch. This is the part sketch, and this will be the blank. So now this blank, I will call it as blank. So now I will write the part program for this profile. So before writing part program, we need to identify what will be the coordinates based on observed coordinate system. So let us take the coordinates. So now I will construct the axis line. Let us take this the center, and let us take this is axis line. Okay. So now for this axis line, we need to calculate what will be the coordinates. So now the coordinates at various points. I will take what is the coordinates at point 1. Let us take this is 0, and let us take this is let us take this coordinate will be the point 0, and this one I will take point 1. Let us take this is point 1, and this one I will take coordinate number 2. This is coordinate number 2, and this one I will take coordinate number 3, and this one I will take this corner. This corner will be the coordinate number 4, and this will be the coordinate number 5, and this is coordinate number 6. This is the coordinate number 6, and this is coordinate number 7, and last one is coordinate number 8. This is coordinate number 8. Okay, so these are the coordinates. We need to calculate what will be the coordinates at these points. So now the coordinates at point 1. So I'll write what will be the coordinates at point 1. So now coordinate at point 1. Let us I will go to point 1. Point 1, the coordinates are x and z value. We need to enter what is x and z value. So x is at point 1, the x is, the diameter is 40. X is 40 mm, and z will be the 0. Z will be the 0. This is coordinates at point number 1. And similarly, coordinates at point number 2 is x is same 40 mm, and z become minus 35. So minus 35 will be the z value. And similarly, coordinate number 3, x is it is 70 mm will be the x, and take x is diameter. X is 70 mm, and z will be the 35 mm. So these are coordinate at point number 3. Similarly, coordinates at point number 4. The x is diameter. So diameter at point number 4 is 70 mm, and z will be the length from point 0 or from the reference. So the length is 35 plus 20. So it is 40, 55, minus 55. So minus 55. And similarly, I go to point number 5. So at point number 5, the coordinates are x is same, x is 70 mm, and z is minus 55 plus 7, that is 57, 63. Minus 63 will be the coordinates at point number 7. Next, I'll go to point number 6. At point number 6, the coordinates are x is same diameter, that is 70 mm, and z is minus you have 40. You need to add plus 40, means 103 minus 103. Yeah, minus 103 will be the coordinates at point number 6. Next, go to coordinates at point number 7. The coordinates at point number 7 is diameter. So diameter is it is how much? Diameter is 105 will be diameter, and Z value is point number 7, 103 plus 25. So that is 125, 26, 27, 28. Z value. Then if you go to the 8 one, so 8 one is x is point number 8. X is total length. X is diameter 105, and z is minus 150 coordinates at point number 5. Okay, so these are the coordinates we calculated. Now by using these coordinates, just 2 minutes, I will come back. Okay. So now I'll write the program for this profile. So first we need to write the program by using G71 cycle. Then after that write the program for grooving operation. Grooving operation. See, while writing the program for G71 cycle, don't consider external grooving operation. Without considering external grooving operation, write the program by using G71 cycle. I already explained in the class. Then after that, change the tool and write the program for grooving operation by using this scan cycle. So now I will write the program. So now, before writing any part program, do I have observation book? Give them any one program. Do this side. So follow.
It's clearly this.
No, don't this one. Do it this side.
Clearly this.
I want to make it. Okay. Okay, it's understood now. It's okay. I'll write while explaining program. I'll write it. Okay, so now I'll start the program. So before writing any part program, you need to specify program name. You need to specify the program name before writing any part program. Let us take the program name. So let us take program name is I'll take some A, use capital letters A and some numbers. Say I'll take 0, 1, 2, 4, 5. So this is the program name. Okay. So after writing the program name, you need to specify the billet. So what will be the billet size or billet dimension? So now I go to billet. So billet dimension is you have x and z value. So x is what is the diameter? So diameter I took 110. So that is the x value and z value. So z is the total length of the part. So total length of the billet. So we assumed 160 will be the total length of the billet. So then next one is I'll go to the now I'll start writing the program. So now before writing part program, you need to specify the block number. Let us take block number N01 will be the block number 1. So all dimensions are in matrix, so I'll use G21. G21 means dimensions are in matrix, G21. And next one is speed rate, I'll assume in terms of mm per minute. So that is G98. So I already explained this concept while explaining G71 cycle or rough turning cycle. So next I'll go to the second block N02. So send reset the tool or send the previous tool to its reference point or home position. So that is G28 and you have U0 and W0. So U and W are secondary moment of tool with respect to workpiece. So next block N03. So N03, I'll go to the next block N03. Next, we need to switch on the coolant before performing any machining operation. This M08 will be the coolant on and switch on the spindle. Spindle on in clockwise, I'll use M03. Spindle speed, I am assuming 1800 RPM. 1800 RPM will be the spindle speed. So next, after that, I will go to the next block N04. So before performing any machining operation, we need to select the tool. So tool selection is N06 will be the tool selection. I am using tool number is T01. T01 will be the tool number. So this is the tool I am using for G71 cycle or rough turning cycle. I am using this tool. Okay. And similarly, so next one is I'll go to the N05. I'll go to N05. So here I will bring the tool to this reference point before performing machining operation. Let us assume this is a blind, so I will bring the tool somewhere here. I'll assume these coordinates. So that is the coordinates I am using before performing machining operation, or before using G71 cycle. I'll bring the tool to this point. Say I am showing in the cursor. So there I will bring the tool. So what is the coordinates at this point? So there's a rapid movement. So rapidly I will move the tool. Say you have a tool turret somewhere here. So I'll move the tool rapidly from tool turret to this position. So at this point. So the coordinates at this point is the rapid movement. So it is a G00. The coordinates x and z value. The coordinates at this point is x is diameter, right? So the maximum diameter of the workpiece is 110. So let us take 1 mm. So I will use 110 only. I will use 110. 110 will be the moment of the tool along x-axis, and z will be the 0. Let us take z will be the 0. So that is a rapid movement. So I'll move the tool rapidly to this point. So next, after moving the tool rapidly to that point, the next step is use the cycle. Use the cycle. So the cycle it is N05, not NO. It is N05. Now I'll use the cycle. So cycle is N06. So I'll go to the next block, N06. Now the cycle is used G71. Use G71 to perform machining operations. Okay. Use G71 to perform machining operations. So that is. So now I'll use G71. So G71 rough turning cycle. Then you have U and W. U is minimum depth of cut. I am giving minimum depth of cut is, let us take 1.2 mm will be the minimum depth of cut U, and R will be the retract value. I am assuming retract is 1.5 mm will be the retract. These two are assumption. U and W are assumption. N06. Next I'll go to N07. I'll go to N07 and it is G71. N07, G71. You need to specify the P and Q. P is starting block number. See, the starting block number is after N07. The next block number is N08. Will be the starting block number P, and you have Q. And Q is the end block number. It is unknown, so I will enter later the Q value. PQ and U, W and F. U is finishing allowance in X direction. I am assuming finishing allowance in X direction is 0.01 will be the finishing allowance in X direction in mm, and W is finishing allowance in Z direction in mm. So I am assuming 0.01 mm will be the finishing allowance in Z direction. And then you have feed rate. Say assume feed rate is so let us take 75 mm per minute will be the feed rate. Okay, so this will be the G71 cycle syntax. G71 UR, G71 PQ UWF. I already explained in the previous class. So next I'll go to the next block N08. So now tool is here, somewhere here tool is here. So now I'll move the tool from here to here, 0, 0. I'll move the tool from here to here, or we can move the tool from tool turret to this point number 1. Here no need to do any machining operation here, or else you can bring the tool from here to here. Then you can move the tool from 0 to 1, 1 to 2, 2 to 3, and so on. So now I will move the tool. While moving the tool, we have to use G01. I'll use G01 and the X and Z value. We need to enter. Anyhow, Z is 0. Z is 0. Enter only X value. So X is take a diametrical value. So X is 40 mm. So X is 40. X will be the 40. Then I will go to the N09. I'll go to N09. Then it should be G01 only. It should be G01. So next I'll move the tool from, see now the tool is at the point number 1. So that is 40, 0. I entered X only. Z I am not entered because in previous block I already mentioned Z is 0. So I will enter only the X value. So next I'll move the tool from 1 to 2. So 1 to 2 is a linear interpolation. Enter the X and Z value. See here no need to specify G01 because in previous block I already specified. If you want, you can specify it. It won't be a problem while executing the program. So N09, enter the coordinates at point what is the coordinates at point number 2. X is 40, so here x will be the 40 and z will be the minus 35 will be the z value. So this is n9. So next I'll go to n10. I'll go to n10. So now the tool at the point number 2. So now I'll move the tool from 2 to 3. So the movement should be a linear, vertical movement. It's a linear. Again, it is G01 only. So no need to specify G01 in the 10th block. Okay. In the 10th block, no need to specify. No need to specify G01. So next one is. So now it is specify only x and z value. So x is 70. So now x become 70 and z become 35. It should be a minus. Z become it's 35 minus 35 and z is minus 35. Okay. So now in the next block, I'll go to the next block. So next block is we have N11. We have N11. Then next one is now tool at 70 and 35. 70 and 35. So now I'll move the tool from 3 to 6. So directly instead of moving the tool from 3 to 4, 4 to 5 and 5 to 6. So I'll move the tool directly from 3 to 6 because in between 3 to 6 we don't have any step or we don't have any taper or we don't have any contour. Okay. Don't consider groove while writing G71 cycle. Neglect the groove, that is 4 to 5, and write G71 cycle. So now I'll move the tool from 3 to 6. So 3 to 6 will be the linear interpolation and coordinates at point number 6 is 70 and it should be Z is minus 103 will be the coordinates. So now I'll go to the N12. I'll go to N12, block number 12. So now tool is at point number 6. So I'll move the tool from 6 to 7. So 6 to 7 is linear, it's a taper. So taper means we have to use G01. It's a linear interpolation. So 6 to 7. So I'll move the tool from 6 to 7. It's a linear interpolation. So enter the coordinates at point number 7. So x is 105 and z is minus 128 will be the z value. So next I'll go to the next block N13. I'll go to N13. So now tool is at point number 7. I'll move the tool from 7 to 8. Again it's a linear interpolation. So we have to use G01. So coordinates at point number 8. So that is x. Use x is 105 and z is minus 150. Okay, so now we completed all the coordinates. The next step is we need to specify what will be the q value. So you need to specify the q is 150. Okay, so please specify the q value is q is 13. Q should be 13. To specify q13 because here I am unable to edit the q value. You can mention the q value is 13. Okay, so now the next step. Now I completed rough turning operation. The next step is send this tool to its home position. So N14. So now I am sending this tool to its home position to perform next operation. So next operation is external grooving operation. So now I am sending this tool to its home position, that is N14, and we have G28, U0, W0, U0 and W0. So I am sending the tool to its home position by using G28, U0, W0. And the next one is, it's very important. So now I am using grooving cycle. So before performing grooving cycle, we need to identify which is the start point of the groove. So from the diagram, say I will consider 4 will be the start point of the groove and 5 will be the end point of the groove. 4 is the starting point of groove, external groove, and 5 will be the end point of the external groove. So now I will move the tool rapidly. So I already sent the tool to its home position. After sending the tool to its home position, the next step is we need to call grooving tool to perform grooving operations. So now I'll go to N15. See, I'm using different color because from here onwards we are writing the program for external grooving operation. So N15. So I'll go to N15 and I will change the tool. Change the tool means we need to call the tool. So what is the code we have to use to call the tool or to change the tool? We have to use M06, and the tool number say I will use T02, T01 for rough turning cycle, that is G75 cycle, and T02 for external grooving cycle or external grooving operation. So I will use a T02. Okay. So next one is, I'll go to the next one is N16. I'll go to N16. So now we need to bring the tool rapidly. We need to bring the tool rapidly where we need to start the grooving operation. So generally as per the sketch, so I will start the grooving cycle at point number 4. Therefore I will bring the tool rapidly from tool turret to point number 4. So that is a rapid movement of tool. Rapid movement of tool means it is a G00 and move the tool rapidly at point number 4. So what is the coordinates at point number 4? It is 70 and 55. So now the coordinates is 70 and Z will be the 55. So that is a start point of grooving cycle. So from point number 6, I'll start grooving from point number 4, I will start the grooving cycle and I will end at point number 5. Okay. So I'll change the tool. First I will send the initial tool to its home position and I will change the tool. Then after that I'll bring the tool rapidly at point number 4, then use the grooving cycle. I am using the syntax. I am using the grooving cycle syntax. So N17 and it is I'll go to G75. So I'll go to G75. I'll go to G75. Ganesh, you have software? You don't have laptop? Oh, then how to show the execution? Whether it's working or not?
You can share the screen with software.
Where is the software? I don't have software. I don't have software in my laptop. Okay, anyhow, tomorrow we will do one thing. Tomorrow you type the program in a notepad and save this program. And tomorrow morning session we will execute this program. Okay, after that we will go to next one, thread cutting operation. Okay, next I will go to N17. N17. Suppose tomorrow if you are not coming. Okay. So now I will go to the N17, G75. So I will go to G75. I am using the syntax G75. R will be the retract value. Let us assume a retract is 1 mm. You can assume any values, 1 mm or 0.5 or 1.5 or 2 mm. So that is a retract value. So next one is I will go to N18. Next block N18 and G75. Then X value. So X nothing but it is a diameter of the groove. So as per this sketch, so diameter of the groove is, what is the diameter of the groove? So this diameter is 70. So 70 minus, what's the diameter of the groove? 70 is there and I think you are getting this 10 mm, 10 mm. So we are getting 50 mm. This is 50 and this is 70, right? So 50 mm will be the diameter of the groove. You can check the diameter. See, diameter means from here to here. Look at the cursor. From here to here will be the diameter of the groove. So this is 50 mm. This is 10 mm. This is 10 mm. And this is 70 mm. 70 minus 20 become 50. Okay. So diameter of the groove is 50 mm. And next one is I'll go to the length of groove from the reference. So generally we need to refer generally the length of groove is 7 mm. This will be the length of the groove, and we have to take Z value from the reference. From the reference means from 0, 0. From the reference, the Z value is 35 plus 20 plus 7. So that is 35, 45, 55, then 57, 58, 59, 60, 62. So Z value is 62 from the reference. 62 will be the Z value. Then you have, this is XZ, and P is, I told P will be the pecking incremental distance of tool along x-axis. So pecking incremental distance along the pecking distance of tool along x-axis in terms of microns. Say it is, let us assume it is 500 microns, and similarly, let us take Q is another 500. Is the assumption, you can assume any value, 500, 250 or 100 microns. Okay, so that's the assumptions. That is the P and Q. Then you have next one is feed rate. Let us take feed rate. I am assuming some 50 mm per minute will be the feed rate. So this is the grooving cycle. Okay, now we completed the grooving cycle. We completed the grooving operation. The next step is we have next step is I'll go to the next block N19. So next step is we need to identify is there any other operations other than these two. We don't have any other operations. So now I'll assign this tool to its own portion, that is N28, G28, U0, this tool to its own portion, and next one is after sending the tool to its own portion, the next step is switch off the spindle. So spindle off is M05 will be the spindle off, and coolant off, M09 will be the coolant off, and end up the program with rewind. So that is M30. M30 will be the end of the program with rewind. Okay, so this is the program we are using for this profile. Okay, see diameter, I will explain about diameter of the groove. What is the diameter of the groove means? Just look at this diagram. So the distance between from ear to ear is diameter. So this distance, so this diameter, will be the diameter of the groove. This is diameter of the groove. We are getting 50 mm. So this side is 10, this side is 10, and remaining is 50 mm. That is the diameter of the groove. Okay, so that is the X value. X nothing but diameter of the groove. Next, Z means from ear to ear. We need to mark Z value from ear to here. Don't take 7 mm. So this is Z value. See, this distance is Z value. So we need to measure this distance. So that is Z value. And P and Q is assumptions. That is stepping and pecking and stepping distance in terms of microns. I am assuming 500 and 500. F will be the feed rate and R will be the drag. Okay. So this is the the program for this profile. Okay. And in examination you will give only this profile. You need to take, you need to assume say this is 0, 0. See this coordinate, this, and this will be the 0. So this is 0, 0. This is 1, 2, 3, 4, 5, 6, 7, 8. So initially don't consider the groove and write the program by using G75 cycle, then send the tool to its home portion, then change the tool and identify where is the initial point of the groove, 4 will be the initial point of the groove, and use the cycle and complete. Use the cycle and send the tool to its home portion. So that is a grooving cycle. Okay, so now in this profile there is given only single groove. Suppose if I have multiple grooves, how do you write the program? Let us take, there are two grooves. There are two grooves in a profile. So how do you write the program? Okay. Okay, so is it clear? So tomorrow, so today I don't have software in my laptop, and tomorrow we'll feed this program in the software and we will try whether we are getting output or not, or we will cross check is there any errors in the part program. Even I don't know whether we will get the output or not, so we need to verify by using the software. Okay, so now I'll share one more. You can take the screenshot, or you can take the screenshot of this one so that it is very easy to write the program. Okay, grooving syntax I mentioned, sketch is there, and program is also is there in the screenshot in the screen. You can take better. You can take the screenshot. So next we will. I will go to one more problem. Just I'll give the program. I'll give the profile. Try to write the program, and we will see. We will see in tomorrow whether we will get the output or not. Let us take one more program. So I'll go to the next program. See, if you have any doubts, just you can raise your hand. And those who are not completed the record, you complete the record. Thursday I will conduct lab internals. Thursday. Tomorrow, today is Monday, and tomorrow I will complete thread cutting operations. Thread cutting operation, and day after tomorrow I will leave. We can practice, go through all the programs. Those who are not completed the record, you can complete the record. And Thursday I will conduct internals as per the timetable. So Monday morning one batch, and afternoon another batch. Okay. So I'll show the program in Okay, I'll put the program. I'll put the next problem in the WhatsApp group. You can cross check. You can try to write the program for the given profile. Okay, and tomorrow I will explain about external thread cutting operation. So what is external, how to perform thread cutting operation by using CAN cycle. So that is last operations left in CNC turning. Okay, milling we already completed, and turning we completed rough turning operation. It includes step turning, plane turning, and taper turning operation. And today's class I explained about grooving operation, external grooving operation. And tomorrow I will explain about thread cutting operation. See, generally in grooving, how to make a groove on a cylindrical object by using a CNC turning center. Okay, so I will post one more sketch. Go through your WhatsApp, check your WhatsApp. Maybe in another 5 to 10 minutes, I will share the one more problem. Check the WhatsApp and try to write the program. Okay, when you come to the college, you can execute that program by using the software. Suppose those who have softwares, so you can execute that program and check is there any errors in the part program. Okay, so now. Okay, you can take the screenshot of this image and this program. So I think now it is 11:30. Okay, I'll stop the today's session, and we'll see tomorrow. So afternoon you have, I think you have a design lab. So you can attend design lab, and afternoon also I am handling. I am taking the same program. I'll explain the same program in afternoon session, maybe at 1:30. Okay. Those who are missed the today's session, today morning session, you can attend afternoon session. Okay. So I will stop the session for the first batch, and we'll see tomorrow. And I will send some of the images. You can write the program and execute.